Very good morning. This is Dr. J. Balaji, Associate Professor, Department of Mechanical Engineering, Erode Engineering College. Uh, Today, are going to be seen about the turning moment diagrams and flywheels. So, before going to see about this entire topic, first of all, where we are now. So dynamics of machineries. In dynamics of machines, we have a second part of the first unit. This area. So first of all, turning moment diagrams. So initially, we need a concept of a turning moment diagram. So we could be understand first of all what is flywheel. So flywheel is a mechanical device. How this flywheel is functioning in our engine. So it is most important. You know most about the basics of the flywheel. So because the flywheel is a very important part which is given the supply to the engine. How in what way the power can be given to the engine of this flywheel, and flywheel how can we store the energy from the engine. The flywheel initially I'm saying supply the energy to the engine, but at the same time the flywheel can store the energy from the engine. So the both supplying and storing the both work they can perform. How it is performed well. Okay, some reservoirs we know the reservoirs, water reservoir, oil reservoirs, or otherwise you take a example of electrical reservoirs. I mean that electrical reservoirs is battery. Battery is one of the best example for the electrical reservoir. In that battery, the energy can be stored in the form of chemical energy. Like that, in the flywheel. Okay, flywheel which store the energy in the kinetic form. Okay, let me go for one by one. So initially we need the some knowledge about the flywheel. After that we go for the turning moment diagrams and how that turning moment diagrams can be formulated by from the theoretical part. Okay, so in this turning moment diagram and flywheel part, we seen about the turning moment diagrams for various types of engines. So different type of engines we have already. So in the different type of engines, a different type of turning moment diagrams is arrived. Next, for fluctuation of energy, fluctuation of speed, flywheel, energy stored in flywheel, dimensions of the flywheel rims, flywheel in punching press. These are all the syllabus we are going to be covered in this PPT presentation. In our syllabus, we have these topics. So one by one, let me go for complete everything. Okay. The learning outcomes of this presentation, through this presentation, very first, I could suggest this is the very first outcome. List the functions of the flywheel. Just now I'm told what are the uses of flywheel, what are the function they perform well in this engine. Okay, so it is very important function of the flywheel. So for the next learning outcome of that presentation is describe the situations in the flywheels are used, where these flywheels are used. Okay, so flywheel usage is very important, where this is clear cutly used and effectively usage. Okay, then for the third one is third main objective, the function. Okay, wow, explain how a flywheel works in a IC engine. So in without flywheel, IC engine cannot perform well. Okay, so flywheel is a energy supplying device and energy storing devices. Both functions the flywheel can be uh, performed. Okay, then the fourth outcome is describe the significance of turning moment diagrams in flywheel design. So flywheel design is very important because these flywheels are, already I'm saying flywheels are very important to supplying of energy of engine. Okay, so these are all the learning outcomes at the end of this PPT presentation we are covering. Okay, let me go for a synopsis of the presentation. So in this presentation, we have 12 topics, individual topics, and having a much more effective. So now for first introduction. So what is turning moment diagram? This is the introduction part of this presentation. The turning moment diagram for single cylinder double acting engine, four stroke cycle engine, multi cylinder engine. One by one, we have to be uh, formulated. Then fluctuation of energy. What is fluctuation of energy? So how it will be occurred in this engine. Next, for determination of maximum fluctuation of energy. So how we can go for calculate the maximum fluctuation of energy? So fluctuation of energy is a practical case. Every engine cylinder, it will be formulated, it will be occurred. How can we determine this fluctuation of energy? That is also a important task. Then go for a coefficient of fluctuation of energy. Then flywheel, the dimensions of the flywheel, what are the parts are available, what are the design considerations are available, how we can go for important dimensions can be calculated of the flywheel. Using a turning moment diagram systems, we can formulate or we can find out the dimensions of the flywheel. Okay. Next, to go for the coefficient of fluctuation speed, energy stored in the flywheel, dimensions of the flywheel rim. Then the finally for a application, a small application portion can be touched into this area. Flywheel in punching press. Okay, so these topics we are going to be covered in this PPT presentation. Uh, so there are these 12 topics. Can we move for the next PPT presentation? Okay. Okay, next slide. Very first, we move on to the presentation of turning moment diagram. So, what is meant by turning moment diagram? So, how this turning moment diagram can be constructed? Okay, the turning moment diagram, also known as crank effort diagram. It is the graphical representation of the turning moment or crank effort for various positions of the crank. It is plotted on Cartesian coordinates in which the turning moment is taken as the ordinate and the crank angle as abscissa. Okay, students, very carefully you listen these words. So turning moment diagram, which is a graphical representation of the turning moment or crank effort for various positions of the crank. So crank will runs inside the engine cylinder at a different angle positions. Okay, so we take as a input parameters for a turning moments of the crank and turning angles of the crank. In between these two parameters, we construct a one graphical curve. That graphical curve is called as turning moment diagram. Okay, so we could be seen one by one and some in such a case practical explanation with that. Okay, so listen, turning moment diagram for a single cylinder double acting steam engine. Very first, how this can be go for constructed. So in this turning moment diagram, you could be seen about the diagram. Here I am showing on diagram. So double acting steam engine. The steam engine can performs uh, forward and reverse stroke of the piston is exactly 180 degree 180 degree. Okay, so totally 360 degree the piston cylinder can be covered. So every 180 degree a complete cycle, complete half of the cycle can be completed. So a full cycle of steam engine covers 360 degree of crank positions. So they should be drawn in the as represented in a figure, 180 degree and 180 degree. It is a curve which is starts in a gradually with raising up to the maximum torque level, and then again the curve will be decreased in the minimum torque level. Okay, when starts 0 to 180, the curve one half revolutions are completed. Then again curve will starts from 180 degree to 360 degree. As usual, the same path can be traveled and complete in the 360 degree. So this is the turning moment diagram of a single cylinder double acting steam engine. So the formula can be represented here. The torque value of the formula, torque T equal to Ft into R sine theta plus 2 plus sine 2 theta divided by 2 root of n square minus sine square theta. So this is the final torque equation of single cylinder double acting steam engine. Okay. While we are going to be solve a problem, we can use this formula is very important. So I'm explaining the curve such a few minutes ago. So here the explanation is given. Okay, let me explain. From the above expression, we see the turning moment is zero. It is maximum when the crank angle is. It is maximum when the crank angle is 90 degree and is again zero when the crank angle is 180 degree. So the crank position is maximum at the angle of 90 degree and again it falls down at zero. In that time the crank passes to the 180 degree. Okay, again this is shown by the curve ABC. Okay, clearly you see the figure ABC. A small ABC represents the 0 to 180 degree. Next, the curve CDE is the turning moment diagram for in stroke and is somewhat similar to the curve ABC. Okay, so you just watch the curve CDE, which is similar to the ABC. So, just now I told a single acting double cylinder steam engine can follow the action is yeah, 180 degree forward, yeah, 180 degree and reverse. Okay, both the strokes can power can be produced. Okay, therefore, since the work done is the product of the turning moment and the angle turned, therefore the area of turning moment diagram represents the work done per revolution. So here you watch one important line T mean. Mean torque of the turning moment diagram is mid of that given figure. For a you just watch a line of T mean A B C D E F. The capital A B C D E F, which is representing the mean torque line. Okay, so this is fully the explanation of the turning moment diagram of a single cylinder double acting steam engine. So while we are going to the problem, it will be cleared further addition, right? Okay, next we move on to the turning moment diagram for a four-stroke cycle internal combustion engine. Okay, let me continue. Turning moment diagram for a four-stroke cycle internal combustion engine is shown in figure. Clearly here show it the figures. We know that the four-stroke cycle internal combustion engine, there is one working stroke after the crank has turned through two revolutions. All of you know about this point is very clear. So there are two complete revolutions. Okay, two complete revolutions only we get a one power stroke. Okay, we know that the four stroke cycle internal combustion engine get a one working stroke after completion of two turning revolutions. Okay, that means the 720 degree, the complete two revolutions. All of you know about the concept of four stroke internal combustion engine. We have a cycles of four strokes: suction, compression, working, and exhaust. Okay, so suction stroke, which is the main working for this area is when the suction stroke air will be sucked in inside the engine cylinder. Okay, then the compression. Compression is a um, uh, air is intake. Okay, that air can be compressed by means of given the high compression tension of this high compression of the air at the end of the compression stroke. In that compression stroke, the piston will move from bottom dead center to top dead center. Okay, so at the end of the top dead center, the sudden explosion is occurred. So why this sudden explosion is occurred? At the end of the compression, the maximum compression is achieved in the cylinder. Yeah, yes, yeah, fuel particles. Okay, yeah, fuel particles can self-ignited and burned suddenly. Then all the ionized particles can be burned a fraction of second. Okay, that fraction of second sudden burning, a piston can goes from top dead center to bottom dead center. This stroke is called as working stroke or power stroke. In that stroke, the crank will receive the power from the piston. Then crank will deliver this power to the cylinder. It's a flywheel. Okay, in that area, the flywheel can store the energy in the form of kinetic energy. Okay. Then finally, the exhaust stroke. All of you know about that clearly. The exhaust stroke will exist the all the unburned gases and remaining unburned fuel mixtures. Everything should be exhausted through this stroke. Okay, this is the working of that this four-stroke cycle engine. Okay, so how was the turning moment can be constructed in the multi-cylinder engine? So multi-cylinder engine turning moment diagram is clearly representing on the figure. It is very clear the multi-cylinder engine during this curve, the separate turning moment diagram for a compound steam engine having three cylinder and the resultant turning moment diagram as shown in figure. So here I'm showing a three cylinder. That means multi-cylinder means more than the two cylinders or more than the one cylinder is called as multi-cylinder engine. Okay, so the multi-cylinder engine will performs the work in the sine waves, the model of sine wave. Okay, so the diagram is clearly representing. The resultant turning moment diagram is the sum of the turning moment diagrams for the three cylinders. It may be noted that the first cylinder is the high pressure cylinder. Okay. Second cylinder is the intermediate cylinder and third cylinder is the low pressure cylinder. Maybe we consider like this. Okay. What was that? What was the turning moments? Okay. So the turning moments will follows as like this, right? Okay. Next to move on to the fluctuation of energy. So what is fluctuation? Fluctuation is all of you know the meaning of the word fluctuation. Fluctuation means the variations of in the terms of electrical systems. The fluctuation is the low voltage or the power is very low in. So like that we are saying fluctuation in the form of mechanical energy systems. What is fluctuation? So power developed of the engine is very important. That power can be stored also, yeah, very important. Okay, so uh, when we can store the power from the engine to the flywheel, it is constant ratio. If we could not be stored the power of a flywheel, the engine cannot be supplying a full form of the power, because the power developed to the engine cylinder is variation. How this is the main important question: how the power can be varied in engine. Well, you consider the practical situation when we are traveling in the vehicle in upstairs movement. Okay, upstairs movement, the fuel supply is more, but the speed of the vehicle is slow. because the torque of the system is high, okay, then the speed of the system is very low. So how all of you know about the already we know torque is inversely proportional to the speed. When we have a more power, when we need a more power, the vehicle can engine can run up much faster. Okay, the gear system acquiring the first gear system. Okay, so in that situation, the fluctuations is occurred. So during the energy storage level, okay, during the energy storage level, the fluctuation is much more high. So fluctuation is a practical case we need to be solved in this type of engine cylinders. So while we are solving a turning moment systems, fluctuation of energy is important. Okay, what is the maximum range of energy level and what is the minimum range of energy level? Okay, this is the range of fluctuation of energy. Okay, so here all of you see the definition of fluctuation of energy in the last line. Just you watch the last line. The difference between the maximum and the minimum energies is known as maximum fluctuation of energy. While running a complete cycle of engine, maximum energy to the minimum energy. The difference between maximum and minimum energy level is called it as maximum fluctuation of energy. So fluctuation of energy is nothing but the energy above and below the mean resisting torque line are called as fluctuation of energy. We have an average value of each and every energy systems, right? So that average energy level which is stored from the engines is above and below mean torque lines. So okay, this is fluctuation of energy. Okay. So next we move on to the calculation of maximum fluctuation of energy. How we can calculate the maximum fluctuation of energy? For example, we taken as here a multi-cylinder engine. Multi-cylinder engine, just now I told the energy level up and energy level low is the common platform of the diagram. So in the crank and turning moment diagrams, the diagram can be clearly shows ebb and flow shape. Okay, so this ebb and flow shape curved diagram is the diagram of a multi-cylinder engine. Okay, let me clearly explain. Here, uh, just you watch the energy level at B point, energy level at C point, energy level at D point, energy level at E point, energy level at F, then G. Okay, the entire system having a energy at point E. What it means that just you come here the first point. So A is A equal to E. For example, every engine having a internal energy. Okay, every engine having initial energy. You consider the initial energy is E. Okay, E is the available energy of engine. Okay, these available energy are already having energy, whatever it may be you consider. Okay, so A equal to E. Okay, this is the point A. So point A equal to E. This is the available energy. Now, the crank will move at the position of B. The energy level in this area, energy at B equal to already available energy plus the curved. Okay, in this curve having a point A. Okay, so energy plus A1 point at B. Then point at C, energy available energy plus A1 minus A2. So why we given the symbol of minus here means it is a negative energy. Okay, so above the mean torque and below the mean torque line values are categorized in the positive and negative energies. Negative loops, it is called it as negative loops. These negative loops are very dangerous one. That means it will be pull down the engine energy. Okay, that means the fall downs of the energy. It is called it as fall down of the energy. This is push up the energy. This is fall down of the energy. So up to the complete energy scenario, the finally at the point of G, energy at A. So what is the initial level, that is the final level. So energy can be formed destroyed, it is continuous process, and then it will be supplied to the other remaining works. So this is the maximum fluctuation of energy calculation one. Okay, here the formula, the last one, the formula can be clearly given, maximum energy minus minimum energy. Okay, next. Okay, now we see in coefficient of fluctuation of energy. So first of all, I told the definition. What is coefficient of fluctuation of energy? It may be defined as the ratio of the maximum fluctuation of energy to the work done per cycle. Mathematically, it could be represented as CE, C suffix E, maximum fluctuation of energy to the work done per cycle. So we know this maximum fluctuation of energy in every engine cycle, okay, or every cycle, we have a maximum energy, we have a minimum energy, okay. Difference between the maximum and the minimum energy, we know that the fluctuation of energy. So coefficient of fluctuation of energy, a parameter can be considered as maximum fluctuation of energy, okay, by the work done per cycle. So maximum fluctuation of energy, at the time only the engine can perform well, that is the available energy engine will take and run completely. So that's why we can take as maximum fluctuation of energy. Due to this maximum fluctuation energy, how much amount of work can be performed the engine. So because this in between this, the ratio is called it as a maximum fluctuation of energy. Okay, so one by one the formula also can be derived. Work done per cycle equal to T mean into theta. Okay, so T mean into theta, we know that T mean torque, then theta angle turned in the crank, it is on revolution. Okay, then mean torque can be calculated, all of you know about the power formula. So power equal to 2 pi nt divided by 60. From that formula we can calculate the turning moment values. Okay, so turning moment equal to T mean equal to P into 60 divided by 2 pi n. So all of you know about the omega, angular position or angular speed of this given rotary component is omega 2 pi n by 60. So can be supplied and T mean can be calculated. Okay, then coefficient of fluctuation of energy again, the work done per cycle. What is work done per cycle? How much? P into 60 divided by N. Okay, power into 60 divided by N. So here some set of coefficient of fluctuation of energy for steam and internal combustion engines are given. A single cylinder double acting steam engine. So CE value 0.21, cross compound steam engine 0.096, single cylinder single acting four stroke gas engine 1.93, like that another two cylinders are given. If needed we can take this in our problem. Okay, so up to this we completely see about that the major points on the turning moment diagrams, how the turning moment diagrams differed, and how the turning moment diagrams can be constructed, what is the fluctuation of energy, coefficient of fluctuation of energy, and then how we can calculate the maximum fluctuation of energy, the del E values. So this is very important for turning moment diagrams, but these entire applications are related with the flywheel. So we need to study about flywheel is very important. So next we move on to the important topic of flywheel. Already I'm saying the flywheel is an important component of engine. Without flywheel we cannot run the engine at a important stages. Okay, flywheel, without the flywheel engine cannot run. uh, Without the engine flywheel cannot also be run. Okay, by vice versa only. So flywheel is very important a component of engine systems. Okay, let me go for explain the flywheel systems of our engine. Okay, so very first what do you mean by flywheel? Okay, here the you just see the first paragraph of the flywheel. A flywheel used in machines serves as a reservoir which stores energy during the period when the supply of energy is more than the requirement. Okay, please understand the word. When the supply of energy is more than the requirement, and release it during the period when the requirement of energy is more than the supply. Very clear statement. So flywheel is used to supply of energy when energy is lower in the engine system. Then when the energy is excess in the engine system, the flywheel can receive the energies from the engine. So there are the two functions the flywheel can be performed very well. So in case of steam engine, internal combustion engines, reciprocating compressors and pumps. Okay, the energy is developed during one stroke, and the engine is to run for the whole cycle on the energy produced during this one stroke. Okay, in case of steam engine, like that, the flywheel can be working. For example, internal combustion engines. Okay, in case of internal combustion engines, the energy is developed only during the expansion or power stroke. In few slides later, a few slides before, I'm told this. The energy is developed only during the expansion or power stroke, which is much more than the engine load. Okay, so engine load maximum, the engine load, the energy can be sucked from that one and stored in the form of kinematic energy. Okay, and no energy is being developed. Oh, I'm told already. Remaining the three strokes, there is no energy developed during the suction, compression, exhaust stroke. In case of the four-stroke engine, already we seen that. The excess energy developed during the power stroke is absorbed by the flywheel and released it to the crankshaft during other strokes in which no energy is developed, thus the rotating the crankshaft at a uniform speed. Okay, so these points already I'm saying at the time of explanation of working of four-stroke engines. Okay, so so above considerations, what is flywheel? How you can be crisply defined the flywheel? Just you watch the last paragraph. A flywheel controls the speed variations caused by the fluctuation of energy in turning moments during each cycle of operation. So, which is very clear. They say, well, if flywheel is mainly used to supply the energy when the fluctuation of energy occurred in the engine system. Okay, only the engine maximum energy developed at the time of power stroke on. Okay, but the remaining stroke, the energy levels plays a very poor level. Okay, suction, compression, and then expansion. So in that time, in that situation, the flywheel can supply the energy. When the power stroke, the flywheel can receive the energy from engine. Okay, this is the major function the flywheel can be do. I think all of you understand this is very clearly. Okay, so that's all about the flywheel introduction. uh, so from this is the flywheel is a application part of this portion. That's why the flywheel is play a vital role in this area. Okay, the coefficient of fluctuation of speed. So what is coefficient of fluctuation of speed? So earlier we seen about the coefficient of maximum fluctuation of speed. Here, okay, listen. Coefficient of fluctuation of speed. The difference between the maximum and minimum speeds during a cycle is called as maximum fluctuation of speed. Okay. The ratio of the maximum fluctuation of speed is to the mean speed is called as coefficient of fluctuation speed. So the formula is clearly explained. Mean speed is n1 plus n2 divided by 2. The coefficient of fluctuation of speed is Cs. It is represented as Cs 2 times of n1 minus n2 divided by n1 plus n2. The formula is clearly indicated here. So when while we are going to be solve the problem for turning moment diagrams, the formulas are very important for finding the coefficient of fluctuation of speed values. Okay, coefficient of fluctuation of energy we can calculate it already by using of the formulas, and I could explain. Now this is coefficient of fluctuation of speed. Okay, then energy stored in the flywheels, how in what form the energy can be stored in the flywheel, already I'm saying the energy stored in the flywheel in the form of kinematic energy. Okay, kinematic means the rotational form of the energy. Okay, due to the centrifugal force acting on the rim or hub or arms of the flywheel. So these are all individually can save the energy, because the flywheel is a biggest unit and a big mass of the system. So whole mass of the system can store the energy inbuilt. Okay, in the form of kinematic energy, half mv square, already we know that. So we, from the basic formula of the kinetic energy, E is equal to half mk square, mv square. This is the formula for Newton's law. From this base formula, we can apply all the input values and find the final form of maximum fluctuation of energy of the flywheel is del E equal to m r square omega square cs. So this is the important formula for saving of energy of flywheel. So energy stored in the flywheel can be calculated by using of this important formula del E equal to m k square omega square cs. Okay, so sorry, here I am showing the formula del E equal to m k square omega square cs. Okay, so this is the final formula. So the energy can be stored in the flywheel. Okay, important formula. By using of this formula, we can solve everything in the problem. Okay. Okay. So up to this presentation, we covered the turning moment diagram systems of a multi-cylinder engine, single-cylinder four-stroke engine, single-cylinder double-acting engine. Okay, then multi-cylinder engines are all the systems where we considered to complete this everything one. Now we conclude this session. In this session, we completely seen about everything of turning moment diagrams. Next, we move on to the practically we solve one or two problems for understanding of these theoretical concepts, and we will enlarge that numerical ability by solving a more number of problems. Thank you. Thank you for patient listening of these presentation videos. Thank you, everyone.